first presentation is titled Proper Preparation, the Importance of a Sound Substrate, and is presented by Scott Wendling from Sauereisen. Scott Wendling has over 20 years of experience surrounding the wastewater industry, specializing in coatings and CIPP lining. Scott is a Utah WWC operator for and has an associate degree in civil engineering. He has not only worked in the municipal side of the wastewater collection, but has also owned and operated a sewer cleaning, inspection, and trenchless rehabilitation company providing coatings for manholes, lift stations, and other wastewater structures. So Scott, if you share your screen, we're ready for the kick this day off.
Perfect. All right, here we go. Good morning, everybody. Proper preparation, the importance of a sound substrate. So the trenchless sewer rehabilitation industry has come a long way over the years, especially with its advancements in concrete manhole rehabilitation. Specifically, types of products that are available, epoxy coatings, polyurethane coatings, cementitious coatings, cured in place bag liners, polymer inserts. Bottom line, you've got a lot of choices of products to choose from. So making sure you're getting one that's formulated for wastewater and that environment is critical. Impacts of population growth. As cities get more congested, rehab becomes more and more favorable from a cost standpoint, time, and just in general disruption to day-to-day lives. Aging of infrastructure. Goes without saying, a lot of our sewers were put in years and years ago, and they continue to get put in every day. So every day things continue to get a little bit older. More contractors performing wastewater rehabilitation and other applications of protective coatings for new construction. So as products have evolved and the number of projects we see year to year have increased, so is the number of more contractors. This is especially important as we want to assure that all contractors are doing quality work. So how do we do that? Well, we want to make sure we're working with qualified manufacturers and certified applicators. So when you're starting a program, you want to verify that the manufacturer that you're working with has a coating system that is designed for the wastewater industry, and how long have they been doing that? Might seem like a crazy question or comment, but in all reality, we see, we've seen it time and time again. A roofing contractor tries to bring a roof coating into the wastewater industry, and it doesn't work out so well. Verify that there's a certification program. Again, we want to see certified applicators out there on your projects and doing quality work. Verifying the contractor's experience. Everyone starts somewhere, but what we don't want to see is a contractor get in over their head. So if you put out a project that's really large and the contractor doesn't have a lot of experience with large projects, it could end up costing everybody. And we want to avoid that at all costs and as much as we can. So what are some of the common issues that we deal with in wastewater rehabilitation, specifically manhole rehabilitation? The biggest thing is microbial induced corrosion. We reference it as MIC. Basically, we have atmospheric conditions, which is your hydrogen sulfide gases. Those, along with temperature, humidity, ultimately create acidic surfaces in our manholes and ultimately lead to severe deterioration. One other element is infiltration and inflow, so I&I. But we'll go into MIC a little bit deeper here. So what is microbial induced corrosion? Basically, microbial induced corrosion results from the pH of concrete lowering over time and due to ongoing exposure to hydrogen sulfide gas and condensation, sulfuric acid forms. So it can be kind of described in 3 stages. Concrete, when poured, starts at a higher pH of 12 to 14. Stage 1, the carbonation stage, that pH level starts dropping, and in stage 2, it continues to drop, and ultimately stage 3 continues to drop more. This has become because conditions become favorable for the growth and reproduction of numerous bacteria. Like I'd mentioned, temperature, moisture, nutrients, and surface texture. In some of our hotter climates, we see manholes deteriorate faster than in colder climates. Basically, a biofilm is being created using the hydrogen sulfide gases generated from the sewage in a respiratory process, and this ultimately secretes the sulfuric acid in what's known as the vapor zone. And this is what starts eating away the manhole. So here's just a diagram. So we got a wastewater flow, got some hydrogen sulfide gas that starts coming up. The biofilm develops, pH continues to lower. The bacteria oxidizes the hydrogen sulfide and creates a sulfuric acid. This, again, is the biogenic attack above the water line in the vapor zone, and this is what deteriorates our manholes. Here's a short video showing that surface concrete of the structure, how it's getting eaten away by that acidic attack. This is what we have to address. So if we don't take care of the substrate of this surface, then we're going to have failures in our coatings. So here we have another manhole. Again, highly deteriorating. Definitely time to make something happen. Okay, so this brings us to poll question number 1. Do you currently have an active trenchless manhole rehabilitation program? So basically, we see CIPP projects with manholes, we see CIPP projects without manholes, we see manhole projects alone. Bottom line, we get asked a lot about, how many manholes do I have to have an effective program? In all reality, there is no number, but don't think that you have to have hundreds of manholes put out to bid for a contractor to come and bid your work. In all reality, if you had 10 manholes and you did 10 manholes every year, a lot of contractors would be just happy to continue to bid that work for you. So a good program is never too late to start, and it can be as small or as large as you wish it to be. Okay. So infiltration and inflow. Well, the first thing we're going to address when we get to a manhole before we start washing it is there any infiltration? Infiltration is simply water that's coming in joints, seams, cracks. This can be in your manholes, your pipe as well. Inflow is more of your storm events, high water. Maybe you got a manhole that sits low in a grassy swale area, and when it fills with water, that water is coming through the pick and eyes of the lid. So not so much dealing with the inflow in this particular case, more of the infiltration. And so we just want to, how are we going to take care of that? Basically, some of the tools You're going to see a contractor utilize is oakum, which is essentially just a dry jute rope, and that's utilized to fill larger cracks and separations in the manhole seams between your barrel sections. Got a port, which is the orange device there. We drill a hole with a healthy drill, hammer drill, and then also airless paint sprayer. So chemical grout injection is probably your most common and preferred method of doing infiltration control, utilizing a hydroactive polyurethane grout. So a hydroactive polyurethane grout is basically water activated. So as soon as the material comes in contact with the water, it starts to activate. Typical materials will activate in 45 seconds or so. Can take longer, can take shorter. Some of that depends on the water temperature. So really good for crack and joint or seam injection. Fills voids as well as it has an expansion of up to 40 times its volume. So if you think about it this way, if you've got infiltration in your manhole, chances are there's also soil coming in with that water that's coming into the area. So ultimately you could be creating a void outside the manhole where that infiltration is. So having an expanding foam, gives you kind of a seal, not only from the water coming in, but it also helps fill that void out there and secure the ground. Most of the materials that I'm familiar with are NSF approved. And this just really means, it's safe for potable water, safe for the environment, just a great product. How's it packaged typically? You can get it in single cartridges, twin cartridges, as well as 5-gallon pails. So if you're using the high pressure pump, you're going to typically be, mixing a couple gallons at a time in a 5-gallon pail and injecting from there. We also have a fast setting hydraulic cement. That's just what it is. A super hot cement that you pre-mix and it'll kick off in about 15 seconds. And you can place this over a leak in the barrel section, and that'll allow that water to be stopped as well. This is more of a surface band-aid, if you will. That's where the hydrophobic grout, polyurethane grout's a better solution because you're actually putting it into the soil, encapsulating the structure, pulling the material through. So the most two common things we see leaking in manholes is your boot leaks leak a lot, and then of course the seams where your barrel sections are stacked onto the base. So if you'll notice on the right-hand picture, contractors put some oakum into the seams. That oakum is probably saturated with the grout, and that's why you see the foam there. And then they're kind of pushing that material. You'll see the big waterfalls, and this is you're just trying to control the flow of water. So rather than have water coming out everywhere in the seam, you only have a couple spots that it's coming out. All right, on your boot leak, I'm going to drill a hole. Typically, we want to be under the leak as foam rises, and then typically a couple feet away. Again, you want that material to activate. Middle picture, you can see the brown colored water. Right-hand picture, the leak is stopped. Okay, once the infiltration is stopped, you can remove any of the excess grout. You'll notice that top seam in this particular manhole has got mastic sticking out of it. So we want to remove that mastic as well. Stairs are, if your program calls for stair removal or not, that's up to you. If you're dealing with really old manholes that have the old steel stairs, chances are those stairs are not doing their job anymore and becoming very unsafe to use anyway. Manholes are a confined space anyway, so you should really be on a tripod. So just removing those stairs makes good sense. If it's a newer manhole and they got the plastic stairs, that's a toss-up. Okay, so now you're ready to wash. So surface preparation of existing concrete. So we want to remove all contaminants such as greases and oils. This is especially important, like if you are doing some infiltration, because you are getting those, that chemical grout spilling everywhere. And so we want to really, really remove all that stuff. Suitable surface preparation methods include abrasive blasting or water blasting. Abrasive blasting is, using an aggregate, or the water blasting would be a industrial pressure washer capable of at least 5,000 PSI. It's really important that we develop a surface profile. This gives the coating a surface to bond to. So when we are doing our washing, we're looking for a surface profile of what's considered an ICRI surface profile CSP 426. ICRI is the International Concrete Repair Institute, and the CSP 4-6 off of the CSP comparators, and I'll show you those here in a second. We also want to ensure a minimum pH of 8. We already know that these manholes are being deteriorated because of acidic deterioration. So when we're washing them, we're not just removing that deteriorated concrete surface. We're also wanting to make sure that we get the acidic acids out of there as well. So here's your ICRI comparators. They come 1 through 10. The number 1 being the smoothest surface, number 10 being the roughest surface. A 10 has a profile of about 1/4 inch in depth. So if you look at the right-hand picture, on the right-hand side, you got your number 4 CSP, and then a number 5 as you work your way to the left, and then number 6. So somewhere in here is what we want to see. That we can achieve good adhesion, with these profiles. pH testing, just a simple litmus test, can be done, several different ways. They have a tape that you pull off a piece and stick it on there. But bottom line is, proper pH testing will make sure that we've removed any acidicness. That way, again, we're dealing with good adhesion. So equipment. So as far as abrasive blasting goes, you're going to have, standard sandblasting pot. You can either do wet blasting or dry blasting. So depending on the situation, if you're in a manhole, if you're in a larger structure, just what's going to work best for you. Lower pitchers, just an industrial power washer. Again, biggest thing here is you want to choose a good pressure washer that's industrial grade. It's going to create a 5,000 PSI pattern for you. Top middle pitcher. This is, I guess, your Cadillac of the industry. So this would be a vac trailer with onboard water. Also has pressure washer included with it. So not only can you vacuum out the debris that you're washing off the manholes, but the pressure washer's right there with you. So that's a pretty nice unit in itself. Okay. Then we've got the right-hand pitcher. We've got an operator that's washing a manhole. And I guess we want to point out here that, they're using a rotating nozzle or what's otherwise known as a turbo nozzle. So the nozzles that are utilized also make a big difference. You buy a pressure washer, it's going to come with your standard 15-degree, 25-degree, and 40-degree tips, but a turbo or rotating nozzle works really well. Okay. So existing structures, again, we drop into existing manholes, got a lot of deterioration. What are we dealing with? First and foremost, confined space. We've got atmospheric conditions to deal with hydrogen sulfide gases. Large pipes, fast flows. So safety becomes a huge concern for the crew that's going into the structure. Tools being used. I bring up tools just from the standpoint of, I've seen multiple operators drop mason's brush into the flow line just to find it down in the sewer lift station a few days later, maybe clogging a pump. So you just want to be, have your contractor very well aware of their tools, and if they do drop one, let you know. Of course, you're going to run into loose, deteriorated concrete. That's the whole reason we're in here. How bad is it really? Haven't seen very many structures in my lifetime that were not rehabilitatable, but they do exist. And in fact, if sometimes you get asked, when do I stop washing the manhole? Well, you stop when you stop removing material. And if that means you're removing material until you hit dirt, then you probably need to reevaluate that structure and get an engineer on board with what's going on there. An exposed rebar. Key points in washing. So we always want to wash from the top down. This obviously, for obvious reasons, keeps your dirty material from contaminating your clean material. High pressure, 5,000 psi. You want to protect the flow, the sewer flow, from any falling debris. So depending on how deteriorated a manhole is, you could get a little bit of debris off the walls and or you can get a lot. This particular picture shows an operator washing the ring. I always find this to be important. The rings are always rusted, so washing that rust off of there and making sure that after you do the coating, you're not dumping a bunch of flakes of something onto your coating is always good to do. Again, rotating turbo nozzle works best. Comfort. Sometimes we don't think about this, but if you've got a 20-foot deep manhole, how are you going to wash every inch of that manhole and be comfortable doing it? So, make different types of bosun chairs that, you can sit in, that work well with your confined space equipment. And take your time. That's probably the most important thing for a contractor when washing these manholes, is not to, miss areas, because you are washing a small area at a time, but that nozzle is not very big. So how do we protect the flow? Here we've got an operator that's placed a couple pieces of plywood that they've cut on the bottom there. So when they start washing, that debris will land on that, not go down the line. Then they can either bucket it out or use a vac truck, vac trailer. Shot of that turbo nozzle and work being used. You'll notice how close they are to the wall. Again, even though you've got high pressure, sometimes it's important to get as close as that. You want to remove everything you can. Okay, so here's a 1 foot section, 2 foot section. Those look pretty good. We start seeing more deterioration as we move down. And we've got quite a bit of deterioration in this lower barrel section. This is our turbo nozzle and work So we're just, removing that failed concrete. So you can imagine how much material that truly is. So again, protecting the flow line from just dumping that material down in there is important. Okay, exposed rebar. So again, jump into a structure, start washing it. You can tell on the left side of this picture that hasn't been washed yet. That concrete is definitely deteriorated and is gonna come off. And obviously, right hand of the picture, after removal, we're actually down to, exposing rebar. So we just want to make sure we clean and remove all the rust. Get that rust off the rebar, so it stops deteriorating that in itself. If rebar is loose, we're going to remove the concrete around it so we can pack some new grout and make it stronger again. Apply a rust inhibitor over the exposed rebar as well after you've gotten the rust off of it before over coating the structure with concrete. Okay, surface preparation. New concrete. So we'll just go into this fairly quickly, but new concrete versus old concrete. Obviously, we're dealing with a little bit newer materials. So perform plastic sheet or calcium chloride test to check for moisture levels. And this can be done, like I said, there's an ASTM standard that talks about plastic sheet testing as well as calcium chloride testing, but quick 24-hour test that can be done to see how much moisture is in the substrate of your concrete. Again, you want to remove all contaminants such as foreign release agents and oils, abrasive blasting or high pressure water. Typically, we'll see more abrasive blasting in new construction. Surface preparation, again, we want to achieve that CSP 4 to 6 as called out by the International Concrete Repair Institute. All right, poll question number 2. Do you require coatings on new manholes being installed on large sewer trunk lines? So seems like a pretty straightforward question. We put a lot of money into sewer projects, and by coating the manholes that are on sewer trunk lines, you're basically adding insurance to your system before they start deteriorating. Sewer trunk lines just typically tend to be more, receive more gases than our smaller distribution lines. So, if you do have a program, or if you are, great. If you're not, highly recommend it. Okay. Plastic, here's your ASTM standard 4263 on the plastic sheet test. We've got basically you can use tape or a caulk to put an 18 by 18 inch sheet of plastic on wall or a floor, and then you check that in 24 hours to see what type of moisture is present. Okay. So new structures. We'll talk about these briefly because they are important from a not a rehabilitation standpoint, but a coating standpoint. You're just dealing with a little bit, you're dealing with new concrete. So you've got maybe some cleaner surfaces on, and this goes for clarifiers, digesters, large wet wells. So what are we dealing with? Again, confined space, new concrete. So is it cured? Typically, we want to see a 28-day cure on our concrete, and we know it's fully cured and ready to receive its protective coating. Issues with the pour. So forms, we can have form issues. Was the concrete vibrated? get rid of air pockets. Again, receiving a good surface profile that I cry CSP 4 to 6. Here's some form issues that we might run into. We got an operator that's running a diamond bit grinder, cleaning up the surface. Certainly wouldn't want to try and coat over that. Abrasive blasting. So here we got a clarifier and they're abrasive blasting the walls. Again, trying to get, remove any latency, remove any, expose any of the bug holes that might be there, and getting us a good profile. One thing to bring up in terms of abrasive blasting, especially in confined spaces, if you've never done this, it can be quite challenging to see, even with ventilation, big fans blowing in, trying to, clean out that area, whether it's wet blasting or dry blasting. Dry blasting with a dustless media. This particular picture is dustless media, so take that for what it's worth. Wet blasting, kind of the same deal. You're typically dealing with atomized water, so it is easier to see, but still a concern. Bug holes. So when you abrasive blast a new concrete wall, depending on how well that concrete settled in, you could be exposing these bug holes. So we want to address those prior to coating. So this brings us to our substrate resurfacer. So we've addressed any infiltration. We've washed our manholes down. Now we're ready to, clean up our joints, seams, bug holes. So why are substrate resurfacers important? Well, we're going to eliminate the potential for entrapped air. So we, ultimately concrete's a breathing material. So we're going to achieve fewer pinholes as well as voids. Okay. We're also going to create, we want to create a uniform subsurface to apply our top coat. We don't want to be trying to coat over, big deviations in the substrate material. So this also allows, if we've got a nice uniform surface, this allows for proper implementation of our ASTM quality control tests, such as high voltage spark testing, which is an absolute must, adhesion testing, highly recommended, and of course, getting our thickness correct on our mill gauge readings. Okay, resurfacing materials. So basically, we've got the most common 99% used in manhole rehabilitation is just a fast setting cementitious material. You're typically going on, you're filling 1/4 inch voids, up to possibly 2 inches on a full rebuild. You've got an epoxy modified cement. So if you're dealing with a little bit less deviations in your surface, you're gonna be using that epoxy modified. So things from an 1/8 inch to up to a 1/4 inch. And then if you're just dealing with maybe bug holes on a pretty clean surface, you can utilize a straight epoxy. And we like to kind of say that that's good for that 1/16 of an inch to an 1/8 inch in deviation. So resurfacing existing manholes. Picture here, we've got a cone section coming down. We got that seam. We got that 1 foot barrel section. So we want to make sure, we can't coat over those 2 seams. We want to make sure we grout those seams in. We got some bug holing, so we're going to take care of those as well. So some of the tools utilized, mixing paddle for mixing up your concrete, mason's brush. Anytime we put concrete on the wall, we want to make sure it also has a decent profile. So, Mason's brush works really well to create that profile. Margin trowel, just depending on where you're trying to put material, margin trowel kind of comes in handy. So the biggest thing we typically will see in our structures are the manhole seams. You've got your base section, then depending on how deep your manhole is, and how many barrel sections there are, whether it's a 4-foot section, 3-foot, couple 2-footers. You want to make sure you grout these seams and then brush finish them, give them a nice profile, and then you're ready to move on. Here we've got a contractor using that brush, just filling in some surface area there, and then brushing that material, giving it a nice profile. Okay, what we typically find is you're going to have more deterioration in right above the flow line. So typically that first 4 feet from flow line up is where we see the highest deterioration. That's not always the case, but a lot of times it is. So it might be important that if you get in there, you start washing that structure, you might, remove an inch of material. Well, you might have to go in and do a full rebuild, get some structural integrity back. And that's what this picture is depicting, is they're troweling on some cement and rebuilding that up, getting a nice surface profile. Another manhole, fully cementitious coated, ready for a nice top coat. Okay, we also run into some crazy structures out there. This cinder brick manhole, from the bench all the way up, cinder brick. So there's no way we're going to apply epoxy coating to this. We need to clean up those jagged edges and get a nice clean profile. So we've got a spray applied mortars for that. Same deal here. Maybe some city had some extra bricks laying over, so your chimney section is just cinder blocks. So we're gonna grout those up. Then for the crazy applications, if you've got a highly deteriorated structure, we could gun on material, 2 inches to 4 inches, full cage rebuilds, just depending on what you're running into. So this was a wastewater tunnel, and had to do an extensive build back. So as far as resurfacing goes on new structures, again, the structure itself going to have a nice sound substrate once we abrasive blast it. So here we're going to use something thin just to fill in those bug holes. That epoxy resurfacer I was mentioning, that works great for that. Just trowel it in, trowel it on. Acts as a primer as well. So you do have a recoat window to deal with here. So, all right, termination joints and keyways. Not necessarily always necessary, but in certain circumstances, they become very valuable. Probably the biggest place that I would recommend these keyways is in sewer lift stations. If you take a look at this particular picture, if you notice on the fillet, got some keyways cut into that fillet, as well as the floor. If you think about it, you've got pumps sitting there sucking that water out of the lift station. It's constantly sucking that coating up. So to just rely on the adhesion of the bond to the concrete should be fine, but this is just extra insurance to really help lock that coating down and assure that you've got a long longevity of operation. Because you're gonna have hydro cleaners in there dropping their tubes and sucking things out as well. One more spot would be if you're not coating your flow lines, you're just coating down to the flow. You want to come up about 4 inches on your face of your bench there and cut that termination key just in case you do have some failure. Lastly, dry substrate. Bottom line is we really do want a dry substrate. Epoxies adhere very well to the concrete. The drier the better. There's several options, just straight. You can use heat in the wintertime. You can use just regular airflow. It doesn't matter. So what is the importance of a clean, dry, solid substrate? Basically, it's to stop failures. If you try to coat over something that's wet, it's going to fail. If you don't have solid substrate, it's going to, again, you're going to fail. Poor preparation and a coating not formulated for wastewater result in failure. Adhesion issues, thin or wrong coatings chosen, trying to coat over infiltration. Thank you.
Excellent. Thank you,